Hello everyone and welcome to my channel, and in today's video we'll be discussing about electromagnetic waves, their production, detection and their uses. So let's start. First is radio waves. Radio waves are produced by the accelerated motion of charges in conducting wires. They are used in radio and television communication systems. They are generally in the frequency range from 500 kilohertz to about 1000 megahertz. The AM or amplitude modulated band is from 530 kilohertz to 1710 kilohertz. Higher frequencies up to 54 megahertz are used for shortwave bands. TV waves range from 54 megahertz to 890 megahertz. The FM or frequency modulated radio band extends from 88 megahertz to 108 megahertz. Cellular phones use radio waves to transmit the voice communication in ultra high frequency, that is UHF band. Now next we have microwaves. Microwaves are short wavelength radio waves with frequencies in the gigahertz range. They are produced by special vacuum tubes called tubes that are called klystrons, magnetrons and gun diodes. Due to their short wavelengths, they are suitable for the radar systems used in aircraft navigation. Radar also provides the basis for the speed guns used to time fast balls, tennis serves, and automobiles. Then, microwave ovens are an interesting domestic application of these waves, and this is a PYQ that in such ovens, the frequency of microwaves is selected to match the resonant frequency of water molecules so that the energy from the waves is transferred efficiently to the kinetic energy of the molecules. Now this raises the temperature of any food containing water, and that is how food is heated in a microwave. Next we have infrared waves. Infrared waves are produced by hot bodies and molecules. This band lies adjacent to the low frequency or long wavelength end of the visible spectrum. Infrared waves are sometimes referred to as heat waves. This is because water molecules present in most materials readily absorb infrared waves. Many other molecules, for example, carbon dioxide and ammonia, also absorb infrared rays. After absorption, their thermal motion increases, that is, they heat up and heat their surroundings. Infrared lamps are used in physical therapy. Infrared radiation also plays an important role in maintaining the Earth's warmth or average temperature through the greenhouse effect. Incoming visible light, which passes relatively easily through the atmosphere, is absorbed by the Earth's surface and re-radiated as infrared, that is, longer wavelength radiations. This radiation is trapped by greenhouse gases such as carbon dioxide and water vapor. Infrared detectors are used in Earth satellites, both for military purposes and to observe the growth of crops. Electronic devices, for example, semiconductor light emitting diodes, also emit infrared rays and are widely used in remote switches of household electronic systems such as TV sets, video recorders, and hi-fi systems. Next is visible rays. It is the most familiar form of electromagnetic waves. It is a part of the spectrum that is detected by our human eye. It runs from about 4 into 10 to the power 14 Hz to about 7 into 10 to the power 14 Hz, or a wavelength range of about 700 to 400 nanometer. Visible light emitted or reflected from objects around us provides us information about the world. Our eyes are sensitive to this range of wavelengths. Different animals are sensitive to different range of wavelengths. For example, snakes can detect infrared waves, and the visible range of many insects extends well into the ultraviolet range as well. Next is ultraviolet rays. It covers wavelengths ranging from about 4 into 10 to the power minus 7 meters, which is 400 nanometers, down to 6 into 10 to the power minus 10 meter, which is 0.6 nanometers. UV radiation is produced by special lamps and very hot bodies. The sun is an important source of ultraviolet light, but fortunately, most of it is absorbed in the ozone layer in the atmosphere at an altitude of about 40 to 50 kilometers. UV light in large quantities has harmful effects on humans. Exposure to UV radiation induces the production of more melanin, causing tanning of the skin. UV radiation is absorbed by ordinary glass, hence one cannot get tanned or sunburned through glass windows. Welders wear special glass goggles or face masks with glass windows to protect their eyes from large amount of UV produced by welding arcs. Due to its shorter wavelength, UV radiations can be focused into very narrow beams for high precision applications such as LASIK, that is laser assisted in situ keratomeliosis eye surgery. If I'm pronouncing it wrong, sorry for that. UV lamps are used to kill germs in water purifiers, that is, our ROs at our homes. Ozone layer in the atmosphere plays a protective role, and hence its depletion of chlorofluorocarbons, that is CFCs, gas such as freon, is a matter of international concern. Next up, we have X-rays. Now, beyond the UV region of the electromagnetic spectrum lies the X-ray region. We are familiar with X-rays because of its medical applications. It covers wavelengths from about 10 to the power minus 8 meter, that is 10 nanometer, down to 10 raised to the power minus 13 meter, that is 10 raised to the power minus 4 nanometer. One common way to generate X-rays is to bombard a metal target by high energy electrons. X-rays are used as a diagnostic tool in medicine and as a treatment for certain forms of cancer also. Because X-rays damage or destroy living tissues or organisms, care must be taken to avoid unnecessary or overexposure. Then next we have gamma rays. They lie in the upper frequency range of electromagnetic spectrum and have high wavelengths of from about 10 to the power minus 10 meter to less than 10 to the power minus 14 meter. This high frequency radiation is produced in nuclear reactions and is also emitted by radioactive nuclei. They are used in medicine to destroy cancer cells. Now here there is a table where we'll discuss about the types of electromagnetic radiations, their wavelength range, their production and their detection. A lot of PYQs have been asked from this very table. Uses, we have broadly discussed uses for all the electromagnetic radiations above when I read the paragraphs to you. So first is radio waves. Radio waves are wavelengths of greater than 0.1 meter. They're all radio waves. Their production, rapid acceleration and deceleration of electrons in areals. Detection is by receivers areals. Then next is microwave, and its wavelength range is from 0.1 meter to 1 millimeter. Production, klystron valve or magnetron valve, and detection is by point contact diodes. Then infrared waves, their wavelength range is from 1 mm to 700 nanometers. Their production is of vibrations of atoms and molecules, and detection by thermopiles, bolometer, infrared photographic film. And yeah, one more use of infrared waves is it is used in night photography. Then next is visible spectrum or light, that we call, and its wavelength ranges 700 nanometers to 400 nanometers. Production is electrons and atoms emit light when they move from one energy level to a lower energy level, from a high energy level to a lower energy level. So that is when we see light, and their detection is from our eyes, the photocells and the photographic film. Next is ultraviolet rays. Its wavelength range is from 400 nanometers to 1 nanometer, and production is by inner shell electrons in atoms moving from one energy level to a lower energy level. Detection is by photocells and photographic film. Next is X-rays. Their wavelength range is from 1 nanometer to 10 to the power minus 3 nanometers. Their production is by in X-ray tubes or inner shell electrons. Again, their detection is photographic films or Geiger tubes or ionization chamber. Last, we have gamma rays, and their wavelength range is less than 10 raised to the power minus 3 nanometer, and their production is by radioactive decay of the nucleus. So that sums it up for today's video. We've learned about all the electromagnetic wave, their uses, production and their detection, and their wavelength ranges also. So thank you for watching. Hope it was helpful.